I hope my screen is visible, right?
Yes, sir.
Can I? Okay, thanks. So today we will start new topic, that is a RAG. Basically, the full form is Retrieval Augment Generation. Retrieval Augmentation Generation. Okay, so there are three part: retrieval, augmentation, and then generation. So before that, uh, why RAG is required? And so the main thing is why we need RAG. Why we need RAG. Okay. So if we have to know why we need RAG, then first we have to understand what is the limitation of LLMs. Okay. Any LLM, not just not any single LLM, all the LLM. There are few limitations. Okay. LLM limitations. Okay. So first thing is LLM takes means to train a LLM model. Okay, it takes huge resources and it take time as well. Okay, to train a LLM. Okay, so let's say if I have to train LLM, so there are few things. So the cost is very high. Okay, cost is okay. So to train a LLM, the cost is very high. Okay, cost is very high in the sense the GPU that is required to train a model. So first thing is like GPU. So this there is a, if you heard about NVIDIA, so NVIDIA is a uh, provider of GPU. Okay, and NVIDIA stocks or the current price of those stocks are very high. It is all because because the GPU requirement grown uh, tremendously because of the LLM. When LLM came, this GPU requirement is very high. Okay, so and also to train a LLM, very high-end GPU is required, not the GPU that we people use in most of the laptops. There are different versions of GPU. So currently H100 series is going on, and these GPUs are very costly. Okay, and first of all, we need to know why to train the LLM. Okay, so let's say GPT-4 is there, then it evolved from GPT-3 to right now it is going on GPT-5, right? And they are not releasing every month some new GPT version, right? Because the training cost is quite high, and also let's say uh, if they trained on let's say currently GPT-5 is released, okay, and if you check, there will be some date also. Date in the sense they will tell, okay, GPT-5 has knowledge of till this date. Okay, so let's say for example GPT-5 recently launched and it may have a training, means it trained on a data till Jan. Okay, Jan 25. So you will, if you ask any question, from GPT-5, okay, it will reply or it will give answer only till January 5, 2025. Okay, and it will not provide any answer um, after January 25. So this is the one limitation that it will only ask tell the answer based on the training data that we have provided to the LLM. Okay, and you people may be confused that let's say if you ask any question in chat GPT, there you will get answer. Okay, means the recent answer also. But if you ask any recent question and if you watch it closely, it will use a web search for recent questions answer. Okay, so that is basically adding a tool to GPT-5 so that it can fetch the answer from the web, and then it is just fetching the information from the web to get the latest information. Okay, without that tool, web search tool, it will not be able to tell you the recent answer. So that is the one limitation. Costing, because of costing, they do not frequently train the model. Okay, otherwise every month they can train, right, if the cost is too low, but they are not releasing it every month because the costing to train a model is very high. Okay, and somebody, sorry, I thought so. And in India, many people say that in India people or India hasn't developed any LLM model till now. Sarvam, basically government is sponsored or government given some scheme to fund the company which will develop some foundation model. Okay, so foundation model are those are the model that are built from scratch, not a fine tuning model. Many Indian company like Ola, they have just fine tuned the model and release it to the market, but they are not developed by India from scratch. Okay, so the GPU cost is very high, and because of that, many Indian companies are not able to create a LLM model. Okay, so right now only one company, and there are some other company also. Government has given a grant so that they can develop uh, indigenous LLM model. Okay, so because of the costing only, many Indian companies are not able to develop the LLM because this required a huge, the number of GPUs are quite large and the costing is also very high. Okay. So the costing is not just GPU because GPU is one thing, then electricity to generate or run those GPU is also uh, very high. So electricity is still we can manage, but the main thing is GPU. Okay, so now we understood that every month we cannot train any LLM model. So if you do not able to train the LLM model every month, then it will not have the recent information. Okay, so this is the one limitation. So because of that also RAG is required. Other thing is like, let's say if you want to, so it train mm, the LLM model train on the internet data. Okay, or not just internet, let's say they have collected some other data from other source. So the data that they have provided to the LLM, so LLM will answer only from those data. It will not answer any other question from other source of data. Okay, if that data it hasn't seen, it will not be able to answer. Okay, so that is the thing. So uh, LLM without tools. Okay, understood. Without tools, it or context. It will not be able to answer any question, answer properly. Okay, any question which it haven't seen while training, okay, the LLM. Okay, so that is the problem with the LLM, that it will uh, not be able to answer it properly if it haven't seen the data or it don't have the context. Okay, so some LLM may give answer, but that answer will be wrong. So that we called it as a hallucination. Okay, hallucination means it, it means if you see the answer, it looks real, but if you watch it closely, then that answer will be wrong. For example, let's say if you ask in some LLM uh, who hallucinate. So let's say if you ask what is balance in my account, the LLM may answer, okay, this is your account number and this is the balance. Okay, but that is a imaginary thing for LLM, because the information, it doesn't have your account information and balance information. Okay, so so that answer looks real, but it is not real. Okay, so that we called it as a hallucination. Okay, so hallucination is just giving a wrong answer. Let's say if you ask uh, uh, something, let's say if you ask, give me some YouTube link, okay, for this lecture. Okay, so maybe that YouTube links are imaginary and they do not work. So that is a basically hallucination. And recently, Deloitte. mm, So so Deloitte is a company. Huh. So they basically using AI and they create some auditing report. Okay. Uh, so today only I read one article that with the help of AI, just to reduce the workload, they have used AI to generate the report. So of that company, and means they generate some imaginary data. Okay, which are not correct. So that company basically, the the company whom they are creating that report, that company file a case that you have taken the help of AI to generate the report. So using AI is easy, but to manage it properly so that it doesn't hallucinate, that is the engineering work. And that, for that only companies are paying for. Okay, because right now there are lots of tools and you can do the difficult task also in a short period of time, unless you know how to control it. 95% of or 99% of the work will be done by AI, and but to just to verify whether that is doing correctly or not, 1% where human will be required, and without human it will be very difficult to basically just roll out any LLM app. Okay, so AI engineering is very much required. Engineering in the sense proper guardrails, um, and covering the edge cases where model may hallucinate. So all these things are engineering work and it will be required. Okay. Now again, come back to topic. So hallucination. Okay. So if it doesn't see any data, it may hallucinate, or it may tell that I don't have that information. Okay. Now let's say you are working in some company. Okay. Maybe XYZ company. Okay. And let's say it company asks you to create a chatbot. Okay. Okay. You have created a, let's say, chatbot, but this data, you are using a LLM model, and that LLM model is trained on means till 1st Jan 2025. Okay. And uh, their recent data, let's say currently today's, let's say October 5, they ask you to create a chatbot. Okay. You are working in a XYZ company and they ask you to create a chatbot for this company. Okay. Where in this chatbot, let's say uh, these are like FAQs, frequently asked question, where uh, user can ask any question related to XYZ company product. Okay. Now, and they are using LLM. Okay. So now if any user come and they ask LLM that, okay, what is this product about? Since LLM doesn't have that information, it may give wrong information. Okay. Or it may not provide a right answer. Okay. So this is the problem that they will face. Okay. And while creating a chatbot, you will face. Now, to solve these problems, we need a RAG system. So again, if I LLM limitation, if I summarize in two ways, one is a static knowledge, uh, and context. Second is a context window. Okay. So static knowledge we have seen. Let's say if you give a PDF file to, or let's say in your prompt, you have added all the information as well. Okay. Right. Let's say about XYZ company, and you have added all the information in your prompt. So let's say before passing to the LLM, you have about this company, XYZ company, you have save it in all the information in a string format, and let's say you store in a some variable a. Okay. And then LLM dot invoke, and what you write, a plus uh, then user question. Okay. So a is a information about a XYZ company, and then you have appended that with the user question. Okay. And this will give answer. Okay. Because right now it will have some context. It's a context. So this is the context. Context is nothing but the information from which you want to ask question. Okay. So you have given some context. Now let's say this context number of token is 1 lakh. Okay. Because this about company information, how many tokens? Maybe 1 lakh, for example. Okay. Now if user is asking hi, okay, even if user is saying hi also, so you are so hi may be a 1 token. Every time you are passing hi plus means the question that user is asking, question plus 1 lakh token every time. Okay. Let's say if the so the context window is, let's say, 1,28,000. Okay. So this is okay. So it is come under a context. Okay. Now Here also there is one problem. So every time you are passing 1 point means 1 lakh token, approximately 1 lakh 1 token. Okay. Now, if you are passing for high also, if user saying high, the answer should be high. Okay. The input is 1 and output is also 1. But for high also, if you are passing 1 lakh token, that will be too costly. Okay. So even if you given the context also, it it not able to fully resolve the problem. Okay. So even if it is come under a context window is the total number of input that model can take, maximum number of token that model can take as a input. Okay. Yeah. So even if that come under that criteria also, let's say 1,28,000 and it satisfy at that time also, this context is too lengthy and it will increase the cost because user, let's say if user send 10 message and for 10 message 10 lakh token and for 10 lakh token the input token cost is, let's say for example if I take chat GPT, so I'm assuming just $0.15 per million token. Okay, so 1 million equal to 10 lakh. So $15 means, so currently 90, around 90, the price to rupee to dollar thing is there. So 90 into 15. So it will be, let's say 20 rupees, for example, um, or maybe less than that. So you are paying for 10 chat, you are paying 20 rupees. Okay, so this is just for one user. Let's say if you have a more than if that company is very big and the active user is also big, so let's say if the number of people is 1 lakh. Okay, so you can imagine the cost. Okay, so 1 lakh into 20, so 20 lakh if users send uh, uh, let's say each user send 10 messages, so 1 into um, so 20 lakh message you are paying uh, uh, yeah, so 20 lakh message you are paying 20 lakh rupees. Okay, now so this is one factor is cost as well. Now second thing is, let's say right now that's come under a context window. So since we are passing only 1 lakh token, what if the input token or input length, because the company document can be 1,000 pages or made more than, let's say it may be a 10,000 pages. Okay, and each pages, one pages, the number of token I am assuming, let's say 2,000. Okay, so 10,000 pages into 2 lakh. Okay, sorry, 20,000 or 2,000, sorry. So it will be 2 CR. Okay. And the context window is 1,28,000 of any model. And it may be maximum for Anthropic case, it is around 2 lakh. Okay. Even if it is 3 lakh also, then this 2 CR is out of context window. Okay. So this, uh, so context window is also a problem. Okay. So the two limitation, LLM limitation, because of that we are using RAG. So one is a static knowledge and other is a uh, context window. Okay, so to solve these two problem, and I can write price as well. Okay, pricing. If we input docs in a context window. Okay. Right. So these are the limitation of a LLM. And if we pass means the thing or document in a context window also, then pricing will come. Okay. To solve this problem, let's say if I have a book of 100 pages, okay, 100 pages, and if I pass directly to the LLM, let's say, and let's say for 100 pages, the number of token is, let's say, 10 lakh. Okay, 10 lakh. Okay. And let's say, so 10 lakh divided by 100. Okay. So it is a 10,000 token per page, right? 10,000 token per page. So let's assume I'm asking some question, okay, from this book. Okay. So XYZ document. Okay. Company document. Okay. So XYZ is a company name and it has 100 pages or 100 page document, and this 100 page contain 10 lakh tokens. Okay. So each pages is around 10,000 token per page. I'm assuming. Okay. It will be lesser than that, but I'm assuming, okay, per page there will be 10,000. So now let's say user is asking some question. Maybe what is ABC? Okay. Now let's say I'm assuming this ABC. What is ABC? ABC is in, I'm assuming that ABC is in page this ABC is in page 70. Okay. So instead of giving the whole book to the LLM, because that will not fit into the context window as well, I'm just giving the if I somehow, if I able to figure it out, okay, if this ABC is belong to page 70, then I giving page 70 information plus the user question. Okay. So page 70 information plus user question. Okay. And then I will pass it to the LLM. Okay. I'm passing both this information to the LLM, and then so page 70 information will be 10,000, and user question, what is ABC? It may be, let's say, 7 token. Okay. So if somehow I able to figure it out, okay, based on the user question, I will see the document or PDF, and I will give LLM only that page where the ABC answer is there. Okay. And passed it to the LLM. And then LLM will provide me the output. So this is how we can improve the costing, means reduce the costing. Okay. At the same time, so what we are doing, so let's say maybe I can take some, let's say if I have a physics book, okay, of 10th class, okay, and it has, let's say, 500 pages. Okay. Now let's say if user is asking what is Newton third law. Okay, and user is asking this one. Okay, and then let's say if I let's say assume that if I have some technique based on user question. uh, so the question is what is Newton's third law. So let's say I'm assuming that I have a technique by which I can extract the page number where the answer related to this question is there. So let's say Newton third law is in the page number 121. Okay, this answer, the Newton's third law is mentioned in page number 121. And so let's say if I have page and here it written Newton third law, all the raw information. Okay, section 1 maybe some information. So it may have other information in that page as well, maybe first law, second law, all three law in a same page. But let's say somehow I am giving the whole page information. Okay, 121 page number. And now I have a LLM. Okay, and so I am passing two information to the LLM. What is Newton third law question, and this is a context. I am saying context. Okay, so LLM will provide me the final answer. Okay, now so this is, we called it as a query. Okay, user is asking something, and what we are doing, so I have a 500 pages book. Okay, and from that book, based on the question, what I am extracting page number 121 where the question answer is there. Okay, so this process we called it as a retrieval. Okay, so retrieval. So the first step is based on the user question, we are retrieving from which page the answer is there. Okay, we are basically extracting the relevant page based on user question. So that is called retrieval. Then we are adding retrieval plus query. Uh, so retrieval answer is this one. Okay, the context. So we are adding these two things. Okay, so this addition we called it as a augmentation. Augmentation. Okay, retrieval, augmentation, and then final answer that LLM will generate. So this we called it as a generation. Okay, so this is how a retrieval, augmentation, generation. So so again, if I give you some more example, uh, because this is the only step that's need to be understood properly to work with rack system. Okay, so now assuming let's say uh, I take Murli. Okay, so let's say Murli is giving some exam. Okay, and that exam is basically a open book exam. Okay, Murli giving some, let's say uh, some semester exam. Okay, semester exam, and that semester exam is basically a open book. Open book exam. Open book, I think you all know. In open book exam, basically you can take your book also, okay, to answer the question. So let's say Murli get one question. Okay, so he sees the question is what is or maybe this is explain thermodynamics, let's say thermodynamics. thermodynamics. Okay. So this is the question that Murli came. So this we called it as a query. Okay. This we called it as a query. Okay. Now, so what Murli will do, let's say if Murli doesn't know the answer, okay, what he will do, he will see the book. Okay. He will have a book. He has a book called Thermodynamics. Thermodynamics book. Okay. So based on the question, he will see first what he will see in which page number the thermodynamics answer will be there. Let's say for right now, just for simple case, let's say uh, this answer thermodynamics is in single page. Single page in the sense it don't Murli doesn't have to look into the second page as well. Okay, so let's say this answer is in somewhat uh, page number uh, or maybe if I write chapter 2 and section 3. Okay, and basically this thing is page number, let's say 100. Okay, so Murli able to based on the question he says okay this answer is in page number 100. Okay, understand the process, huh? So now he has the question and based on the question he look for the page number. Okay, and then from that page number he is extracting the things. Okay, and let's say in that page number there are maybe let's say I'm just so in that page number that thermodynamics I'm just assuming thermodynamics topic started from line number 56. Okay, and let's say total in that page number 100 line is there, and just let's say before that some other information entropy related thing is there. Okay, but the answer related to thermodynamics start from 56. Okay, so now now it has this information, and what Murli do, he will pass this page, he will see it, and the main thing is all this information pass to the brain, right? Brain. So and now brain will have two things. One is this thing and other is your question or query. Okay. So brain will decide, okay, now I have a question and I will have some hint. Okay. It can be a hint or you can say anything. Okay. I'm calling this as a context, but you can call it anything that you like. Okay. Now the brain or Murli brain has two things, question, and he sees that this is the answer. But in this answer, entropy is also there. So what his brain will do? It will it brain will process the both the things, and it will extract only the thermodynamics thing, and also it will write in his own word. It will not maybe he will directly typing the exact line that is given written there, but he will try to make it humanize and he will write the answer in his own word. Okay, so the brain is nothing but LLM. Okay, and the information that we extracting, that is a retrieval. Okay, retrieval from, let's say retrieval is nothing but, let's say if you have a 100-page or 570-page physics book and you are extracting the relevant information, relevant in the sense only information that is relevant to the question, not any pages randomly you are extracting any page, only that pages which belong to the question. Okay, so that we call it as a retrieval. Then retrieval plus question, both you are passing to the brain, which is LLM. So these addition of these two things, augmentation is nothing but addition of retrieval plus the question that you are asking. So this is called augmentation, and once brain get both this question and plus retrieval information, then it will process and generate. So that process is called generation. Okay. And in this same thing, you can also insert the prompt as well, means prompt system message. Okay. So this is how the retrieval system, mainly in a broader way, this is how it will work. Okay. So now, so in this first step is, let's say you have a document. That document may be stored in your local system. It can be a Google Drive, or it can be a some cloud platform like AWS, Azure. Their document is stored. Okay. So the whole process, if I show you the block diagram, very simple. So this is a LangChain document where they have given the hmm, already extra. Okay. So this is the document that I have. This is a rack pipeline. Okay. And this document I have taken from the LangChain. Okay. Yeah. So if you see what we have seen, this user query. Okay. And this retriever part. Okay. And that we are passing to the LLM. Okay. But before that, we have to see that embedding and chunking. Okay. Uh, so in retrieval, so first thing is, let's say this is the thing that you have some document. Okay. And that document may be stored in your local system or in Google Drive, Slack. There are LSQL, means any database. Okay. So first step is to load the document. Okay. So through document loader, we can load that document, then split into chunks. So chunk is nothing but, let's say if you have a, as I said, 571 page document. Okay. Just for simplicity, let's say you split into a per page. Okay. Or um, so that splitting, let's say 570 pages document, you split into a 570 part. So each chunk is one page, right? So chunking is nothing but breaking the larger document into a smaller part. That smaller part can be a page, can be a line, or can be a paragraph or multiple paragraph. That rule we can decide. Okay. We can also break that into based on the number of characters, based on the full stop. So there are multiple ways that we will see. So what we have done, first we have given the source to that document where that document is stored. Then we load that document. Then we have to chunk or break that document to smaller part. Then these steps turn into embedding and vector store. So this is the thing that I was talking about, that turn into vector store, retriever. So this turn into embedding and vector store, this process basically will help us to retrieve the relevant document based on user question. So if you see here, the user query, there also we are calculating the embedding, and in vector store, both these things are going. User query and the document embedding, that document that we have loaded and chunked, that embedding also going to vector store, and from based on the user question, it will retrieve the relevant thing. Okay, and then that pass to the retrieval LLM. Okay, so this is just a retrieval pipeline, not a RAG pipeline. Okay, this is just a retrieval pipeline, not a RAG pipeline. In RAG pipeline, this user query will also go to the LLM and then system query as well. Okay, then this answer will get generated. Any doubt till this point? We will see the whole section, all these things: document loader, chunking, embedding, vector store, all these things we will see in much detail. Okay, but overall idea how the rack system work. Okay, the thing that I have shown through some example, and yeah. So any doubt on that thing, or why we are using is still, if it is not clear why we are using RAG, because that is very important to first understood why we need RAG. Okay, then other process embedding all this thing, that will be easy for you to understand. Yeah, any question? I'll anyone.
Sir,
Mhm.
can you once again tell the difference between retrieval and RAG? मतलब retrieval pipeline only and RAG pipeline.
Do not worry about, forget the retrieval pipeline. Okay,
Okay, sir.
because
Yes.
right now it may be confusing. Yeah,
Yes.
just a rack system. Any question on rack system?
So, John,
Mhm.
normally if in rack system like documents, what we are giving, if it is static, it's okay. Whether like if we are giving like if we are doing on some update like if we are updating the document like
Mhm.
in that case we should like the model will change, right? If we the document is static, it's okay, we can use all these things. But what when the situation comes that the document updates, like if we are scrapping or something, something like that. So if the documents updates frequently, so the RAG model should identify that as update and everything. So we will be learning on that also, like if they update the doc, and also and another one is scalable. Like if the documents, if we add more documents, how the RAG pipeline, again we have to train everything, or again it will be done automatically like that.
So in rack system, we are not doing any training or fine tuning. Okay, we will see what is training, what is fine tuning, but just remember, we are not doing any fine tuning or training. Okay, so that is super important in rack system. Okay, now the question is, let's say if every times or let's say some document release uh, within a means, let's say every 2 day or 4 day, it the frequency is, let's say, quite high. Okay, then we need to make some mechanism which basically able to fetch the information, uh, not just fetching the information, it should get triggered when any new document comes. Okay, because to get updated, uh, there are two way. Maybe you can run the whole pipeline every day, means that embedding all these things, vector store, means all the pipeline, complete pipeline you can run once in a day, maybe in the night, because at that time we are assuming that we generally assume that most people do not use the app. Okay, at that time generally this thing happen, uh, but uh, these things can be done very frequently. uh, so that is the advantage of RAG, because it's not that costly and it is very easy to the whole process, like web scraping to document embedding generation, then storing into vector DB. All these are very fast process, and the scalability depend on the vector store. Okay, we will see what is vector store. So vector store is basically just you can assume that you are just encoding your uh, document into embedding. Okay, and this embedding get stored in a vector DB. So there are this vector is DB is they are database which basically store the embeddings. Okay, we will see in future classes all this in much detail. But yeah, so that vector DB mainly there are different companies making vector DB, and the scalability will be depend on which vector DB you are using. Okay. Yeah.
Okay,
So
okay.
here, Anil question about scalability is means let's say means let's say if you have 100 pages now, let's say as a future means in future cases maybe let's say 1 lakh or 2 lakh or 10 lakh documents. At that time, will this system work properly or not? So that his question regarding scalability is that. Okay. So that thing will depend on the which vector store we are using. Yeah. Yeah. Any other question? If you understand today's, uh, Aditya.
One question.
Mhm.
Sir, suppose you told that book example. Suppose if the answer is in 4 or 5 pages, and
Mhm.
the LLM has to access all those 4 and 5 pages and prepare its own answer. So, will the LLM work efficiently, or will it hallucinate in that case?
It will work. We will see how we can extract. Means you can extract multiple pages, and uh, generally we are breaking the book into multiple parts, not just pages. Page is one example I have given. You can break into a sentence basis, means paragraph based as well. Okay. So let's say
Okay.
you have a book and you are breaking that into a multiple paragraphs. Based on the paragraphs, so paragraph will be based on the paragraph, it will break all the books. Okay, means all the book content. Uh, and it let's say if you are asking anything, then it will extract the relevant paragraph. Let's say maybe one paragraph which is relevant to that question in page number 100, one paragraph maybe in page number on 170, and it can extract 5 6 paragraph, and all these 5 6 paragraph can be fed to the LLM. Now LLM has brain, but for brain also to work we need to give information, right? So we are just giving information to the LLM or brain. Okay, now so LLM, if you it's work like how our brain work. Okay, it is lesser than that our brain, but the intuition is like that only. Let's say let's say if we have a book and or maybe let's say if I ask some question, maybe if someone asks what is their account number or balance, I cannot have seen that information, right? So maybe someone who is a can randomly give answer. Okay, this is the your account number and that, but that person know I'm hallucinating. Okay, means I'm giving the wrong information. Now the other person, the other way is I may ask that person to give show me the, let's say that person may not read. Okay, so he just given that document or his bank account and number, balance, all this information or passbook to me. Then my brain will read or I will read that thing, and based on that I will there will be other information as well. But I will tell only that information. Uh, Again, the important is that I have seen, let's say in passbook, there are multiple other things. I have seen as well, but I will answer only that thing which user is asking or that person is asking what is my account number. Okay. So let's say if he asking what is my account number, and I have seen his passbook, in that account number is there IFSC code, name, father name, date of birth, and let's say account balance is also there. But he's means I have seen all this information, but he has just asking what is my account number. So I will just tell, okay, this is your account number. So that is generation, and seeing that thing is like giving context to the my brain. Okay, so once I have the information, I can tell the answer. But for that, I should have that information to give the right answer. Otherwise, I may hallucinate, because um, it's not like that unless we give instruction to the LLM that if you don't know, just say no. Okay. So this is a one guardrail. Guardrail is nothing but adding some, let's say we can tell LLM, you don't have to answer every question. Only the information, if you have a information about that question, then only you can answer. So this is like a one a guardrail, means you are just preventing the LLM from hallucination. Okay, so this is how the things work. Yeah. Any other question?
So basically what we are doing is using this RAG, we are trying to solve solve the limitations of this LLM, like hallucination, static knowledge, and everything.
Ha, right. So hallucination only, let's say if the hallucination come because it doesn't have that information. So RAG solving that thing. Then and also this means many times hallucination we can prevent through prompting, and most of the time, like let's say if you are making some health assistant and if you say do not provide any answer which is not related to health, then you are uh, basically providing some guardrail. Okay, so it is the same thing. Now let's say if you have a um, a traffic, there is a what to call, let's say if you have a in some mandir temple, so there is too crowded, right? So we put, just to avoid the uh, public gathering, what we put some guardrail, like some stoppage, all this thing, right? So here also we, just to avoid hallucination, we provide some guardrail or some stoppage point that you should not answer from this thing. Okay. Okay. Any other question? Okay, so tomorrow class we will see more into, means how we can create a rack system, and we'll see the embedding, document loader, then vector store. Okay, we will try to see all this uh, component that is required to create a rack system one by one. Okay, yeah. Okay, so that's it for today's class. Thanks everyone.
Thank you, sir.
So